In the early 1950s, the British European Airways proposed a compound aircraft called the Rotodyne, which combined the characteristics of a gyroplane, helicopter, and fixed-wing aircraft. It was a structurally complex but practical aircraft with potential for both civilian and military use, and it gained attention from several countries. The original idea was to develop a medium-range passenger aircraft capable of vertical takeoff and landing, with a capacity of 30 to 40 passengers for rapid urban transport between cities. The vertical takeoff and landing capability would also reduce airport costs, and the aircraft could also be developed for military transport. The aircraft received widespread support as soon as it was proposed, not only obtaining official funding but also securing a prototype contract from the United States in 1953. The project had a promising start, but was the aircraft successful in terms of its structure and technology? The Rotodyne had a main body with a square-like cross-section and no distinct tail boom. It had a small aspect ratio single upper wing, with engine nacelles on both sides of the lower wings. A cone-shaped structure at the rear of the aircraft supported a large four-blade rotor, with a horizontal tail installed above the tail fin and twin vertical tails at the wingtips. As a compound aircraft, the Rotodyne structure was naturally unique. It had two flight modes, with a Napier Eland N.E 1.7S turboprop engine installed in the engine nacelles under one side of the wing. This engine had an output power of 2,800 horsepower, driving the propeller installed at the front and each driving an air compressor. The compressed air from the two air compressors reached the rotor hub through their respective pipe systems, then entered the internal pipe of the two opposite blades, and the compressed air entered a lateral nozzle at the blade tip, mixed with the fuel pumped into the independent pipe, and was ignited to generate lateral thrust to drive the rotor rotation. A single nozzle had a maximum thrust of 4.4 knots, and the system was designed with a high level of redundancy so that even if one set of equipment failed, the other set could still maintain the driving force to keep the rotor rotating, producing enough power to maintain the basic flight of the aircraft. During takeoff, the aircraft relied on the pilot to adjust the pitch of the top rotor to generate lift. Once a certain height was reached, the main power of the engine was transferred from the compressor to the thrust propeller, generating forward thrust. At this point, the operation of the top rotor was similar to that of a gyroplane, with each half of the rotor and the aircraft's wing bearing half of the lift. Upon reaching the destination, the engine power was switched back to the compressor for a helicopter-style landing. Although the flight mode was similar to that of a helicopter, the aircraft did not have a tail rotor for balance, mainly due to the low torque produced by the power system, which could be handled by the large area of the twin vertical tails. The tail system was quite complex, with the horizontal tail and the lower half of the vertical tail having air rudders to adjust the flight attitude, while the upper half of the vertical tail could be folded inwards to a horizontal angle because the top rotor blades were too long. When the rotation speed slowed down, the blade tips would sag, potentially striking the vertical tail. The aircraft had a conventional three-point landing gear, with the front landing gear located below the cockpit and the rear landing gear on either side of the fuselage, both of which could be folded forward. This landing gear was somewhat similar to that of a helicopter, and considering the design of the aircraft, it was likely capable of handling the weight of an emergency landing. The prototype Rotodyne made its first flight in November 1957, setting a world speed record of 307.2 km per hour. It also successfully transitioned between flight modes multiple times without incident, demonstrating the ability to hover with one engine shut down and performing autorotative landings like a gyroplane. However, the Rotodyne had a problem: it was too noisy, reaching 120 decibels. Commercial airlines and military forces interested in purchasing the aircraft hoped to increase its transport capacity and reduce the noise level. In reality, the noise from the Rotodyne was not as unbearable as it seemed, with most of it coming from the rotor tip combustion chambers during takeoff and landing, resembling the roar of a rocket engine. This noise, while significant, only lasted a few minutes, as the aircraft either switched flight modes and flew away, or landed and stopped. Even during testing, the noise did not overly disturb the surrounding residents. However, commercial airlines were more concerned. During testing, it was just one aircraft, but in actual operation, it could be a large fleet of aircraft. If complaints led to grounding, the financial losses would be unbearable. As for military use, reducing noise could enhance stealth, which was crucial in military operations. Despite the design department's efforts to develop various noise suppression devices, the aircraft's noise level still did not meet the standard. Even with subsequent proposals for models with greater payload capacity, the company repeatedly assured the authorities that the noise issue could be resolved with additional funding. However, the British government stopped funding in 1962. At that time, the Rotodyne had mature flight control technology, and its flight and transport capabilities were unmatched by most helicopters at the time. It was not only valued by civilian and military aviation in the UK and the United States, but also by commercial aviation in the Tokyo-Osaka route. However, due to the British government's financial constraints, companies unable to secure official funding believed that the future of the Rotodyne was bleak. Even if the noise issue was resolved, it would be difficult to obtain official orders given the state of the British economy. The company's senior management may have considered relying solely on commercial airlines and overseas orders too risky, and therefore terminated the development internally. The only prototype, built with British government funding, was subsequently dismantled and some components were preserved in a museum. The prototype Rotodyne had an empty weight of 9,979 kilograms, a length of 17.88 meters, a wingspan of 14.17 meters, a height of 6.76 meters, a maximum speed of 307.2 kilometers per hour, a cruising speed of 298 kilometers per hour, a ceiling of 4,000 meters, a crew of 2, and a capacity of 40 to 48 passengers.